Let's go with the triggering problems. In CRO, when discussing the theory part, I have a given one point, triggering point T dot P. In T dot P includes triggering voltage level as well as triggering slope. Let us see what is this TVL and TP. Have a look into the data first. There we get some confusion when new terminology. Now let us clearly analyze what is the new terminology. Okay, right. In a single channel analog CRO, X and Y sensitivities are 1 millisecond per division as well as 1 volt per division. Next, the Y input is connected to a voltage signal, VTG, voltage signal 4 cos 200 pi t minus 45 degrees volts. This is our Y input. The trigger source is internal. Hope you remember in our diagram we have shown internal triggering as well as external triggering. Internal triggering is nothing but what? Whatever the output of vertical amplifier we are taking as internal triggering. Level chosen is 0. Triggering level chosen is 0 and the slope is positive Okay, the screen dimensions are 10 centimeter into 8 centimeter. The display on the CRO screen is dash. Come on, tell me what will be displayed on screen? A or B or C or D? Hope D is also visible to you. Yes, right. I'm sliding this up. Now tell me option D. Which one is correct? What is this triggering voltage as well as triggering slope? Hope you remember. This is what the circuit diagram we have taken or the schematic block diagram we have taken when discussing the CRO. Here if you observe, output of vertical amplifier I have taken as triggering point. Here we have a pulse generator and the sweep generator. Here this T point means trigger point, TVL means trigger voltage level, TS means triggering slope. So now let me explain here. Suppose, yes, if I take a sinusoidal waveform, yes, you tell me at how many points we are getting the zeros, please. At how many points we are getting the zero? Like zero crossing detector, let us observe. Here we are getting 1 0. Here we are getting 1 0. Here we are getting 1 0. Yes or no? Right. If you consider this as first zero crossing, if you consider this as second zero crossing, for half cycle of the input, what is produced? What has to be produced? Pulse has to be produced. Here you can consider this like a start pulse. Yes, a start pulse has to be produced. Here a stop pulse will be produced. But only in half cycle you are getting start pulse and stop pulse, which is not appreciable. Which should not happen here. Why? A full cycle of sine wave has to be displayed for us. Yes or no? Right. So here you tell me what change we can take or what correction we can take so that for a full cycle of the sinusoidal supply we get the complete start pulse and stop pulse. For full cycle of the supply we should get start pulse and stop pulse. Means in simple understanding I can say we should not get stop pulse here. Let me use black pen. We should not get stop pulse here. We should get stop pulse here. We should get stop pulse here. Means what we can take? How we can do this? If you observe, is there any difference between this 0 point, this 0 point and this 0 point? Among these three, is there any difference? We have a difference here. Please observe. At this zero crossing, sine wave is going like this, means rising, means the slope is positive here. At this point, the waveform, it is falling, the slope is negative. At this point, again the waveform, it continues, the slope is positive. If we can set triggering voltage level as 0, and if we can set triggering voltage slope is positive, yes, at this point the start pulse is produced, at this point the stop pulse will be produced. Okay, I will give one more example to you, don't worry. Yes, suppose this is what the sine waveform say. This is what the sine waveform say. You tell me, if I take a 1 volt DC voltage like this, if I take a 1 volt DC voltage like this, okay, as a reference, you tell me here one zero crossing is there, here one zero crossing is there, here one zero crossing is there. Here what the slopes are? Positive. Here what the slope? Negative. Here what the slope? Positive. Now you tell me, if I set triggering voltage as 1 volt and if I set triggering voltage level is, triggering slope is positive, now tell me, yes, here the start pulse is produced, here no pulse is produced, here the stop pulse is produced. Based on this start pulse and stop pulse, what happens? My sweep generator, please have a look, my sweep generator will produce the sweep signal. My sweep generator will produce the sweep signal. Or you can also set, let me use pink, you can also set the triggering voltage level as negative or minus 1 volt you can set. You can also set minus 1 volt like this. Minus 1 volt you can take and you can select the triggering slope. You can select the triggering slope. Even you can also select triggering slope as negative. Anything you can select. Okay, is it clear? Right. Triggering voltage, triggering slope has to be selected. Might be have not done in your labs, but it has to be selected by the user. Then only the sweep generator will produce as the sweep signal. Then only my pulse generator will produce as the pulse, thereby followed with my sweep generator will produce as the sweep signal. Is it done? Now let us look into your question. Just have a look into your question. What is the statement given? Yes, the triggering voltage, the triggering source is internal, level chosen is 0. Level chosen is what, sir? 0. Means from 0 it has to start. If you choose 1 volt, from 1 volt it has to start. If you choose 2 volt, from 2 volt it has to start. Is it done? If you choose minus 1 volt, from minus 1 volt it has to start. Right. And the slope is what? Positive. Positive slope. Yes. Please have a look, sir. Please have a look. If you observe this, if you feel this as a CRO screen here, yes, it is starting from 0. The axis would be somewhere like this. Yes. Is it starting from 0? No. And what is the slope here, please? Positive slope or negative slope? Negative slope. But slope given is positive. No, this is not the correct option. Yes. If you observe, what is the slope here, sir? Rising. Rising means what? Slope is positive. But is it starting from 0? Not starting from 0. Even this is not correct. Getting a point, please? Right. If you observe A and D starting from what? 0. We can feel this like 0, sir. Okay. Even this is starting from 0. Okay. Triggering voltage 0 volts, 0 volts. Correct. Next, what is triggering slope? Triggering slope here also positive. Triggering slope here also positive. Here also positive, here also triggering slope is positive. Now, what options are correct? You will be thinking A and D as correct. Yes or no? Please look into the data. What is given? Triggering voltage is over, triggering slope is also over. Now, here one cycle is there, here two cycles are there. Cycle related information, number of cycles, T sweep by T signal. Let us try to calculate T sweep by T signal. If you get N as 1, option A is correct. If you get N as 2, option D would be correct. Is it done? Right. Now, what is N formula? T sweep by T signal. T sweep by T signal. I can also write this as what? T sweep into, come on sir, F signal, right? What is T sweep? What is the screen size given? 10 centimeter screen size given. 10 centimeter screen size given. Scale setting 1 milliseconds per division or centimeters or centimeters. Come on, what is T sweep, sir? 10 centimeter into 1 millisecond per centimeter into F signal. What is F signal? What is F signal? Have a look at the data, please. 4 cos 200 pi t minus 45 degrees. This is nothing but our omega. Omega 2 pi F. Yes or no? Right. 2 pi. Let me write here. 2 pi F. 2 pi F given as how much? 200 pi. What is F from this, please? 100. F is 100. His signal is 100 hertz. All gets cancelled. N equals to 1. n equals to 1. Means positive slope should be there. It has to start from 0 and number of cycles should be 1. Therefore, option A is correct. Option A is correct. Similarly, let us see one more problem. One more problem. Right. Please have a look at the data first. The X and Y yes, hope it is clear now. The X and Y sensitivities of an analog CRO are set as 2 milliseconds per centimeter and 1 volt per centimeter respectively. The trigger is set at 0 volts. The trigger is set at 0 volts. With what slope? With negative slope. If examiner gives trigger is set at 1 volt, means you have to check the waveforms which start from 1 volt. If the triggering slope is set as positive, you have to see the waveforms which is having positive slopes. Okay? Right. 0 volts with negative slope. Yes. An input of 2 cos 100 pi t plus 30 degree volts is fed to Y input of oscilloscope. The waveform seen on the screen is dash. The waveform seen on the screen is dash. Come on, tell me, sir. It has to start from, yes, assume this is starting from 0 with what slope? Positive slope. So this could not be our answer. Next, here it is having positive slope. Yes, even this is not our answer. This one, sir. This one not starting from 0. Positive slope. This is not our answer. Yes, if you observe, this is having negative slope and it is starting from 0 volts. Since we have only one option with negative slope, option A is correct. Next question. A sinusoidal signal of frequency 2 kHz and sawtooth signal of frequency 1 kHz are applied to horizontal and vertical inputs. Hope the statement appears similar, but here the inputs which are applied is different. So for what we have learned, Y input is any unknown signal, X input is internal generated sweep signal. Yes or no? This is unknown signal, this is internally generated sweep signal. Whereas now I am reversing. This is sweep signal, this is sinusoidal signal. This is sweep signal and this is sinusoidal signal for this problem. For this problem, yes, the waveform that could be displayed on the screen is dash. See, we have done n number of examples. I have shown you the way by taking different instants, and the sweep signal different instants given like this, tablet and plot the waveform. Yes, now you reverse this. If you reverse and if you plot the waveform, you will get option B. You will get option B. You will get this shape, please. Is it done? Right. Even if you calculate a number of signals, n if you calculate, you will get n as 2. Number of signals if you calculate, you will get n as 2. Okay? Right. Next Q. If the bandwidth of CRO is given as 10 megahertz, what is the rise time a sine wave have to be produced accurately by the CRO is dash. Bandwidth given and he is asking for rise time. Bandwidth given, he is asking for rise time. Okay, right. So we have two statements. Bandwidth gain product is constant. Bandwidth gain product is constant. Bandwidth into rise time is 0.35. Bandwidth rise time is 0.35. He is asking for rise time. He is asking for rise time. Bandwidth given 10 megahertz into TR equal to 0.35. TR equals to 0.35 by 10 power 6. I can write like 10 power 7. So finally this could be how much? 35 nanoseconds. 35 nanoseconds. 35 nanoseconds. Single step. Okay. Right. Next Q. A CRO is calibrated for 20 volts per division and its sweep circuit is set for 6 milliseconds. Sweep circuit is set for 6 milliseconds. 3 full sine waves with a distance of 2.25 division between their upper and lower extremities appear on the screen. Okay, V peak to peak given as 2.25. Find VRMS and F signal. What is VRMS formula, sir? VRMS formula, V peak to peak by 2 root 2. V peak to peak by 2 root 2. What is V peak to peak? Number of vertical divisions occupied between peak to peak. Yes, which is given how much here? 2.25 divisions into volt per div. 20 volts per division, div gets cancelled, by 2 root 2. So finally your VRMS is 2.25 into 20 by 2 root 2. I don't want to simplify. 2 ones, 2 tens. It is some 22.5 by root 2 volts. Root 2 volts. Value you do on your own, please. Okay. Right. Next. He is also asking for F signal. What is N? Slide this up. What is N? Let me use black pen. N equals to T sweep by T signal. T sweep by T signal. I can write like T sweep into F signal. T sweep into F signal. He is asking for F signal. What is F signal? N by T sweep. F signal equal to N by T sweep. Yes, what is N? 3 cycles are there. T sweep is set for its sweep circuit is set for 6 milliseconds. 6 milliseconds. So what could be this? 0.5. Yes, 3 by 6. 0.5. 0.5 milliseconds. 0.5 into 10 power 3. Some F signal equals to 500 hertz. F signal equals to 500 hertz. Is it done? Clear? 3 by 6, sir. 1 by 2. 0.5. 0.5 into 10 power 3. Yes, it is some 500 hertz. Is it done? Right. This is how you have to calculate VRMS as well as F signal. Only 3 formulas. CRO में only 3 formulas है. A equal to BC format. V peak to peak equal to number of vertical divisions into volt per div. Time period of the signal equals to number of horizontal divisions occupied per cycle into time per div. T sweep equals to total number of horizontal divisions occupied into time per div. That's it. What is N? T sweep by T signal. Triggering voltage level, triggering slope. Based on that, easily can do some problems. Bandwidth, gain product is constant. Bandwidth, Einstein product equal to 0.35. Is it done? This is how the problems will be. Done? Right. Next Q. The deflection sensitivity of CRT is given as 0.2 millimeters per volt. The voltage applied to the deflection plates for a deflection of 3 mm is dash. What is deflection sensitivity formula? S equals to what? Deflection sensitivity. Yes, so many divisions per volt. So many divisions per volt means for 1 volt of applied voltage, how many divisions has occupied? That is what the sensitivity means. Yes or no? Here we are asking for what is the applied voltage. What is the applied voltage? Means applied voltage equals to, yes, so many divisions by sensitivity. So many divisions by sensitivity. How many divisions, please? 3 mm. 3 mm. What is the sensitivity given here? 0.2 mm per volt. 0.2 mm per volt means mm gets cancelled. 3 by 0.2. 3 by 0.2. So many volts. So many volts. I can write like 3 by 0.2. Yes. 3 by 2 into 10 power minus 1. 1.5 into 10 power minus 1. 0.15 volt. This could be the applied voltage. Next interesting question. Have a look at the data, please. A symmetrical square wave of frequency 25 kHz and peak to peak amplitude of 10 volts is applied to Y input of an oscilloscope. The screen appears as shown in the figure. Vertical and time based setting values are respectively dash. When discussing theory itself, I told you in a formula of A equals to BC, two variables can be given and another variable can be asked. Yes or no? Here A and B is given, he is asking for the values of C. Is it done? Right. So let us clearly find the values of volt per div and time per div settings. Please have a look at the figure. If you observe the screen size, I am counting, yes please, horizontal settings, 1, 2, vertical settings or horizontal settings, count this please, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 horizontal divisions and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 vertical divisions. X by Y we can write like 8 by 10 screen. 8 by 10 screen. Okay, right. Observe carefully. You tell me how many vertical divisions are occupied here. How many vertical divisions are occupied? Hope this is visible to you. If you wish, I will zoom out this. Yeah. Yes, hope it's clear for you now. Right. You tell me how many vertical divisions are occupied. If you observe, the screen size I have written with red pen and the waveform which is appearing on the screen represented with the blue pen. Right? Yes. How many vertical divisions are occupied? First you count the full divisions. 1, 2, 3 and 4. If you observe, 4 full divisions were occupied and half here and half here. Half here and half here. Totally 5 vertical divisions are occupied. 5 vertical divisions are occupied. Or you can count like this, half here, 1, 2, 3, 4 and half. Totally 5 vertical divisions are occupied. Next, coming to horizontal divisions. Vertical divisions, number of vertical divisions is 5. Let us find number of horizontal divisions also. Means you have to count from here to here. Yes, you tell me how many divisions occupied? 1, 2, 3, 4, 5, 6, 7, 8. 8 horizontal divisions were occupied. 8 horizontal divisions were occupied. Yes, from the figure that is given, from the screen that is given, we can calculate this. Over. Now, have a look into the data. Have a look into our data, please. Let me, yes. Hope it's clear. Fine. Yes, you tell me please. What is the frequency given, sir? 25 kilohertz. What is the V peak to be given? Peak amplitude or peak to peak amplitude given? Peak to peak amplitude given as 10 volts. Means V peak to peak equals to number of vertical divisions into volt per div. Into volt per div. Tell me, is this deflection factor or deflection sensitivity? Volt per div. This is the deflection factor. Deflection factor which we represent with Z. What is deflection sensitivity? Divisions per volt. Divisions per volt we call as deflection sensitivity. Volts per div we call as a deflection factor. He is asking for this volt per div. Okay. Right. V peak to peak. How much? 10 equals to 10 volts equals to number of vertical divisions. 5 divisions into deflection factor call as some G. Okay, what is G finally, sir? I am writing here. What is G finally, please? Yes, for 2 volts per division. 2 volts per division. If deflection sensitivity is asked, what is deflection sensitivity? 0.5 divisions per volt. 0.5 divisions per volt. Is it done? Right. Next is asking for time-based setting also, na? Vertical and time-based setting. Let us calculate time-based setting. What is the time-based setting? Let's use black pen. Yes. Time-based setting. T signal. Time period of the signal. T signal equals to number of horizontal divisions occupied per cycle. Per cycle into time per div. Into time per div. What is T signal, sir? 1 by F signal. F signal is clearly mentioned 25 kilohertz. 25 kilohertz. 1 by 25 kilohertz. 25 into 10 power 3 equals to number of horizontal divisions occupied. How many horizontal divisions occupied, sir? 8 divisions occupied into time per due. Time per due. If you calculate this time per due, you will be getting what is the value, please? Finally, 1 by 25 into 8 into 10 power 3. You will be getting the value of time per due. Okay, right. Hope you got the point, sir. This is how you have to calculate the vertical and time base settings. Let us see one more question. One more cue. The time per due and volt per due axis of an oscilloscope have been erased. Have been erased. Have been erased here. Yes, they are erased. If student connects 1 kilohertz 5 volt peak to peak square wave, 5 volt peak to peak square wave, SQ means square wave, pulse to channel 1 of the scope and observes the screen to be as shown in the upper trace of the figure. Hope you got the point. As similar to earlier question, when he connects a 5 volts peak to peak square wave with a frequency of 1 kilohertz, he has seen this upper trace, screen represented with red and the waveform which I have represented with blue pen. Is it done? Right. Next, he is asking for what? Suno please. An UK signal, an unknown signal is connected to channel, lower trace is observed to channel 2. To channel 2, lower trace is observed if time per due and volt per due settings are maintained same. Of both the channels are same, then V peak to peak is dash, F signal is dash. Is it done? Earlier problem we calculated volt per due and time per due. Whereas here in this problem, the similar data given to calculate volt per due and time per due, use that volt per due and time per due setting. Use that volt per due and time per due setting to calculate what? V peak to peak and F signal of the second waveform. Is it done? Right. Let us do this, sir. Tell me please, how many divisions has occupied? How many divisions has occupied? If you feel this as a channel 1, how many divisions of vertical occupied, please? V peak to peak or number of vertical divisions. Number of vertical divisions is only 2 divisions. Is only 2 divisions. Number of horizontal divisions. Yes, please. You have to calculate from here to. Yes. Here. How many, sir? It is 4. It is 4. Can we go a bit faster? Right. Tell me, sir. V peak to peak given how much? 5 volts. Directly I am writing. Yes, if you wish, I will write here. Let me slide this down. 5 volts equals to number of vertical divisions, please. 2 divisions. 2 divisions into volt per due. Volt per due. What is volt per due setting finally, please? Volt per due setting I can write as volt per due setting I can write as this 2 goes to the denominator, 5 by 2, 2.5 volts per division. 2.5 volts per division. Even you can also cross check, sir. Cross check. See, total peak to peak voltage is 5 volts per one division. For one division means here to here 2.5, here to here 2.5. 2.5 plus 2.5, 5 volts. Matching, na? Right. Next, let us calculate what is the time per due setting. What is the frequency given? 1 kilohertz. 1 kilohertz. Let me use blue pen and still slide this down. Yeah. Yes, 1 by 1 kilohertz. 1 by 1 into 10 power 3 equals to number of horizontal divisions. Number of horizontal divisions. 4 divisions into time per due. Into time per due. Yes, please. 1 by 1 into 10 power 3. 10 power minus 3. 10 power minus 3. Let us calculate this. Why? Because we require the value to calculate the next value, na? Yes. It is 1 by 4000. 1 divided by 4000. It is 2.5. Yes, we can write like time per due setting. Let me use black pen. Time per due setting. Writing here. Time per due setting equals to 1 by 4000. so many seconds per division, or 1 by 4000. Simply let us take this value 1 by 4000. Hope it's clear. Right, 1 by 4000. Next, observe, he is asking for V peak to peak in the next case. What is V peak to peak, sir? V peak to peak, tell me how many vertical divisions has occupied from here to here, from this point to this point. How many vertical divisions are occupied? 1, 2 and 3. V peak to peak equals to number of vertical divisions occupied, 3 divisions which are occupied into come on, what is the vertical setting we got? 2.5 volts per division, means it is 7.5 volts. 7.5 volts. Next case we require, he is asking for frequency of the signal. What is the frequency of the signal, sir? T signal equals to, yes please, number of horizontal divisions occupied. How many divisions occupied between this point to this point? How many, sir? 1, 2, 3, 4, 5, 6, 7, 8. 8 divisions occupied into 1 by 4000. Yes, 1 by 4000. This is what we got. Time per div. Time per div. He is asking for frequency. He is asking for frequency. This gets cancelled. 1 by, yes, 8 ones, 8 500s. T signal equals to 8 ones, 8 500. T signal equal to 1 by 500 seconds. What is F signal, please? Reciprocal of this, which is 500 hertz. F signal is 500 hertz. Is it done? Right. Next question on the CRO. Question based on probes. The arrangement shown in given figure represent RC potentiometer for measuring AC voltage. What should be the value of C so that V naught by Vn is independent of frequency of the input signal? Here the data given in terms of potentiometer and all, but you have seen the similar circuit with the probes, which we call this as RP, CP, CI and RI, and there we have derived the condition. What is that condition? For the ratio or for the attenuation factor K to be independent of frequency, what is the condition we have written? RP CP equals to RI CI. This is what the condition we got. Here we have to get the value of CI. What is CI, please? RP CP by RI. What is RP given? What is RP given? Yes, I think I have written wrong here. Yeah, this is your CP. Right. This is your RP. This is your CP. Fine. Right. RP CP product should be equals to RI CI, and your RP value 10 kilo ohms, 10 into 10 power 3 into yes, CP value 1 microfarad, 10 power minus 6 by RI 1 kilo ohm, 10 power 3. Both gets cancelled. 10 into 10 power minus 6, we can say like 10 microfarads. This value should be 10 microfarads. Okay, right. Next cue. A CRO input impedance consists of 1 mega ohm parallel with 100 picofarads. Hope this is visible. 1 mega ohm consists parallel with 100 picofarads. Means this is your RP and this is your CP. Sorry, this this is your RI. Why? Because CRO input impedance he has given. CRO input impedance he has given RI, and this is your CI. A compensated 20:1 attenuator is obtained by connecting a parallel combination of, yes. What is the formula we have derived? What is RP? What is RP formula? Ri into n minus 1. Ri into n minus 1. Cp formula we have derived Ci by n minus 1. What is Ri given? 1 mega ohm into 19. 20 minus 1. Here n is 20. 20 is to 1 probe. N is to 1 probe. N by probe. N by 1 probe. Okay, right. Here Ci, what is the value of Ci given? 100 picofarads by 19. But he is asking what? By obtained by connecting a parallel combination of Rp Cp connected in parallel only, na? Rp parallel Cp by connecting parallel combination. Yes, please. These are your values. 19 mega ohms, and here this is 100 picofarads by 19. Is it done? These are what the Rp and Cp values. Next, a CRO with a TR rise time of 15 nanoseconds measures the rise time of a signal which is of 20 nanoseconds. What is the actual rise of the signal? Actual rise of signal. A small note. Suppose if two amplifiers are cascaded, it is having some rise time, which is having some bandwidth, which is having some gain, say. Okay, right. Call this as A amplifier, and rise time, bandwidth, and gain of a B amplifier. What is overall gain? What is total gain equals to? Yes, GA into GB. Overall gain equals to GA into GB. Next, what is overall rise time? Equals to, you can write like rise time A square plus B square. What is overall bandwidth? What is overall bandwidth? Yes, how you write? Gain bandwidth product is constant. Gain bandwidth product is constant. Rise time bandwidth product is 0.35. Overall bandwidth we write as 0.35 by root over T rise time square plus TRB square. Is it done? Right. So with the help of this, let us try to solve the problem given. Let us have a look at the data. A CRO with a rise time of 50 nanoseconds means CRO rise time is given here. Measures the rise time of signal. It is measuring the rise time of signal with 20 nanoseconds. What is the actual rise of the signal? Actual rise of the signal he is asking for. Yes, measuring rise time equals to root over signal rise time, or let us write rise time of signal, or signal rise time square plus CRO rise time square. CRO rise time, or rise time of signal, or rise time of CRO square. Measuring rise time equals to rise time of signal square plus rise time of CRO square. Okay, this measuring rise time also called as overall rise time. Overall rise time. Next, signal rise time also called as actual rise time of the signal. Actual rise time of the signal. Next, what is the CRO rise time? This CRO rise time we call as vertical amplifier rise time. Vertical amplifier rise time. Yes, if we have a look at the data, this measuring rise time he has given as some 20 nanoseconds, and CRO rise time he has given as some 50 nanoseconds. He is asking for actual signal rise time. Actual signal rise time. Actual T actual of signal equals to root over 20 square minus 15 square. Let us find this value. 20 square minus 15 square under root 13.22 nanoseconds. The value is 13.22 nanoseconds. So hope you got the point here. Very important. Overall rise time or measuring rise time equals to signal rise time square plus CRO rise time square under the root. Okay. These two can be given, this can be asked, this two can be given, this can be asked, and all these combinations are possible. Next question, please. A pulse having rise time of 40 nanoseconds. 40 nanoseconds is displayed on a CRO of 12 megahertz bandwidth. Bandwidth of the CRO given as 12 megahertz. What is the rise time of the pulse observed on the CRO screen? Observed on the CRO. What is the, yes, he's asking for overall rise time, he's asking for. Bandwidth given how much? 12 megahertz. Bandwidth 12 megahertz. What is the rise time of CRO? Yes, we can calculate. Bandwidth rise time product is constant of CRO equals to 0.35. Means rise time of CRO I can write as 0.35 by 12 megahertz. 12 into 10 power 6. How much? 0.35 divided by 12 into 10 power 6. Yes, 2.9166 in 10 power minus 8. Means it is some 29 nanoseconds. Approximately I can take 30 nanoseconds. Approximately it is 30 nanoseconds. Next. What is the actual signal rise time? T actual given as 40 nanoseconds. What is the overall rise time? Overall rise time equals to T overall rise time or measured rise time equals to root over 40 square plus 30 square, 3 under root. It is 50 nanoseconds. It is 50 nanoseconds. Done? Right. Next Q. When the horizontal deflection plates of CRO is kept at ground potential, and 30 volt DC applied to vertical deflecting pair of plates. Vertical deflecting pair of plates means, yes, my Y input signal. The bright spot moves 1 centimeter away from the center. With the same setting, if 30 volts AC is applied to Y plates, what is the image that is displayed on the screen? Yes, what you understood? My CRO screen is like this. You are giving 0 volts means grounded. My X input is grounded. What you are giving here? You are giving a 30 volts DC supply. 30 volt DC is given. From the center, what he is saying, the bright spot moves 1 centimeter away from the center. Plus 30 volts na? Yes, attraction of 1 centimeter. 1 centimeter. Now what he is doing? He is giving an AC supply. AC supply with the same settings means horizontal 0. Yes, now here you are giving 30. What is that input voltage, sir? Yes, 30 volts AC. Let us take some 30 sine omega t. 30 volts AC, 30 sine omega t you are giving. What happens? Positive half cycle, yes, attraction takes place from the center. Negative half cycle, repulsion, yes, it comes like this, again it goes like this. Means the 1 centimeter bright spot now becomes a 2 centimeter bright spot. A 2 centimeter bright spot. Already discussed, similar model discussed. From center to top to center to bottom, again to center, and it continues as long as the supply is there. Okay. Next Q. When a sinusoidal signal of 220 volts 50 Hz produces on a CRO, okay, what it is produced? A vertical deflection of 2 centimeters at a particular setting at a particular setting of the vertical gain control. Okay, when you are giving 220 volts, a 2 centimeter deflection is observed. What would be the value of voltage to be applied to produce a deflection of 3 centimeters for the same vertical gain setting? For the same vertical gain setting. Simply, since it is related with the deflection and all, let us calculate the deflection factor. Deflection sensitivity is divisions per volt. Deflection factor is volt per div. Deflection factor, volt per div. What is the voltage that you are applying? 220 volts. You got a deflection of how much? 2 centimeters. Means 110 volt per centimeter. Per centimeter, you got 110 volts. Now what he is saying? To get a deflection of 3 centimeters, what voltage has to be applied? Hope you understood the meaning of this. 110 volts per centimeter means what? If you are applying 110 volts, you are getting a deflection of 1 centimeter. That is what it means. Now, to get a 3 centimeter deflection, 1 centimeter, 110 volts. Yes, to get deflection of 3 centimeters, how much voltage has to be applied? 3 times 110 volts, how much, sir? 330 volts has to be applied. Then you will be getting a deflection of what? 3 centimeters.